Have you ever thought about how we are here right now? How did we actually come to existence? Well, let's rewind around 14 billion years in the past. I'm sure you know about the Big Bang Theory. I mean, there's a whole TV show with the name of it. But let's dive deeper into what the Big Bang Theory is, and also its rival, the Steady State Theory. For starters, the Big Bang Theory talks about how a burst from one point in space created everything we know of and will know of. Time and matter all originated after this massive burst took place. But is this actually how the universe came about? Well, the steady state theory says the opposite, that the entire universe does not have a beginning or an end, where it can continue to exist infinitely. Let's dive steadily into the steady state theory. As I have mentioned before, the universe does have no beginning and no end, allowing it to exist forever, right? We'll come back to this. The steady state theory, as well as the Big Bang theory, implies that the universe expands constantly, accelerating at speeds that are faster than the speed of light. The key difference is that the steady state theory says that the universe will continuously be creating matter. Whether that is in the form of planets or stars, it will not stop creating it, keeping the average density of the universe constant. This is what allows it to be kept alive forever. This theory also follows a principle called the perfect cosmological principle, which states that no matter what part of the universe you are looking at, it will be the same at any time and at any place. This may sound like I made something up for this video, but Hermann Bondi and Thomas Gold thought of this concept, which is the cornerstone of the steady state theory. It may look like I'm saying that the steady state theory is superior and that it is actually true, but it is not, and there are many flaws with this, which get highlighted by the Big Bang theory. The first flaw is in the perfect cosmological principle. This principle was proven wrong due to observations collected by the Bell Lab's Holmdel Horn antenna, which detected a low-level noise coming from all directions in 1964. This noise turned out to be the cosmic microwave background radiation, CMBR. I will make a separate video about the CMBR because of its complexity, but essentially the CMBR is a faint electromagnetic radiation which came around 400,000 years after the Big Bang. The CMBR was crucial in disproving the steady state theory, mainly due to it being evidence that the universe has evolved and has changed dramatically over billions of years, something that the steady state theory says the opposite of. Another flaw was that the steady state theory did not explain the expansion of the universe. Edwin Hubble in the 1920s was observing galaxies through a telescope and monitored them. He studied so many of them and found out that a lot of them were moving away from us, faster and faster. He concluded that this was due to the universe expanding at a speed that is proportional to the distance, i.e., the farther that the galaxy is, the faster it is moving away from us, which is now known as Hubble's Law and has a formula accompanying it. This law, as well as the discovery of the CMBR, are the main reasons why the Big Bang theory is a more reliable one, and the steady state theory is not. I know that this video has been very content heavy, so please, if there's anything that you may be unsure about, write it down in the comments and I can reply to it.